We need to find the rank of the matrix A by reducing it to the normal form. And the normal format of the matrix is, we are having the submatrices as the identity matrix and other matrices to be zero submatrices, right? So we need to change this matrix into this form, and then we need to determine the rank of the matrix. So by applying few row and column operations, we are going to reduce this matrix A into the normal format. I'm having at the first place 2 over here. I need to make this as 1 first. For that, what I need to do, I just multiply the row 1 with 1/2 and get 1 in place of 2. So I'm changing the row 1 by multiplying its elements with 1/2. So we get 1 minus 1, 0 and 3. Writing the rest of the rows as it is. And now I need to make all these entries to be 0 below this leading entry. 1 is the leading entry for the first row, right? Okay. To get 0 in place of 4, just multiply the row 1 with -4 and adding its elements to the row 2. To get 0 in place of 1, multiplying the row 1 with -1 and adding its elements to the row 3. Similarly, multiplying the same row with -1 and adding its elements to the last row to get 0 in place of this 1. So I'm going to apply all these 3 operations together. Second row is changed into 0, 6, 0, -10. Third row is changed into 0, 0, 0, 0. And last row is changed into 0, -1, 1 and -1. So I'm having all these 0 below this first leading entry, right, for the first row. So we have got all these to be 0 below the leading entry for the first row. I need to make all these 2 also to be equal to 0. So for that, to get 0 in place of -1, that is the second column, I need to apply the column operations now. Just making use of the first column, multiplying the elements of the first column with 1 and adding its elements to the second column. To get 0 in place of 3, again I need to multiply the elements of the column 1 with -3 and adding its elements to the last column. So applying the operation, I'm changing the column 2 by adding its elements to the column 1, but column 1 should be first multiplied with 1. Similarly, changing the column 4 by adding its elements to the column 1, but column 1 should be first multiplied with -3. So writing the first column as it is, and second column is changed into, okay, we get 0 over here. So it is 0, 6, 0, -1. And third column is changed into, we get 0 again here. It is 0, 0, 1. And fourth column is changed into 0, -10, 0, -1, right? So we are having this to be 1, 0, 0, 0 and this to be 1, 0, 0, 0 to get the identity matrix. I need to get 1 over here now, right? For that, let me interchange the last row with the second row. 0, -1, 1, -1. And in the last row, we are having the elements of the second row. Alright. I'm having now -1 to be the leading entry for the second row. I need to make this to be as 1, right? But before that, I'm having already these 2 elements to be 0, but I try to make this to be also 0 first. So for that, just multiply the second row with 6 and adding its elements to the fourth row. So I'm changing the row 4th by adding its elements to the row 2nd. But row 2nd should be first multiplied with 6. So row 4th is changed into now 0, 0, 6 and -16. And now in the next step, let's make this -1 to be 1. For that, I'm going to apply the column operation. Just multiply the elements of the second column with -1. That's it. So writing the first column as it is. Second column is changed into 0, 1, 0, 0. We have just multiplied the elements of the second with -1 and writing the rest of the columns as it is. Alright, I'm having 1 over here now and other elements to be 0, 0 for the second column. To get the identity matrix, I also need to get these two elements to be 0. So to get 0 in place of 1, I'm using the column operation. So making use of this second column, just multiply the elements of this second column with -1 and adding its elements to the third column, right? And to get 0 in place of -1, again I need to multiply the elements of the second column with 1 and adding its elements to the last column. So we are going to change the column third and fourth, writing the first and second column as it is. And after applying the operation, the third column is changed into 0, 0, 0, 6 and fourth column is changed into 0, 0, 0, -16. Sorry, this is -16. So we are having these two as the pattern for the identity matrix. Very fine. What else we need to do is now, just try to make this as 1. So for that, we just simply multiply the elements of the column 3 with 1 by 6. So on applying the column operation for the column third, writing the first and second column as it is, and third column is changed into, just multiply the elements with 1 by 6. So we get 0, 0, 0, 1, right? And writing the last column as it is. Still we need to get 0 in place of -16. For that, again apply the column operation. Making use of this third column, just multiply the elements of the column third with 16 and adding its elements to the last column. So changing the column 4 by adding its elements to the column third, but column third should be first multiplied with 16. So writing the first third column as it is, and fourth column is changed into now 0, 0, 0, 0. I'm finding here 3 by 3 identity matrix, but for that I need 1 over here. Then we will get our 3 by 3 identity matrix, right? For that, let me interchange the row third with row fourth. So now we are getting a very beautiful matrix in a normal form. This is your 3 by 3 identity matrix. And rest we are getting the 0 submatrices, which is the required format for the normal form. So identity matrix of order 3 and other are the 0 submatrices, right? So this is a reduced matrix in a normal form, right? Okay. Now to determine the rank of this matrix, I'm having the identity matrix of order 3. So the number of non-zero rows are 3. The rank of the matrix, the given matrix A, is equal to 3. Right? The rank is the number of non-zero rows in the normal form. So that are equal to 3. So the rank of the given matrix is 3. Alright, thank you. Stay blessed.